Hi, everyone. Just wanted to take a minute to talk about different word problems that you could encounter when you are dealing with inequalities. We will have spent a decent amount of time this week working with word problems and different ways to know inequalities. But here's a couple pre-made stock examples based on things that I know you all care a lot about. Like, for instance, in this first one, William and Deborah Pierce are celebrating their 20th anniversary by having a reception at a local reception hall. So much fun. They have budgeted $5,000 for their reception. If the reception hall charges a $70 cleanup fee plus $36 per person, find the greatest number of people they may invite and still stay within their budget. Now, you could argue about whether or not they could find a better deal somewhere else, and I don't know what the heck they're doing for their 20th anniversary that is costing them $36 per person. But then again, I've also never rented a reception hall. So, that being put aside, let's actually just solve the problem based on what information is given to us. So we know that they have $5,000. So that's their budget. They can spend up to $5,000. They could spend exactly $5,000, or they could ideally spend less than $5,000. But based on the way the problem is written, they're saying find the greatest number of people that they may invite and still stay within their budget. So we're trying to get as close as possible to spending that $5,000. They really want to have a huge shindig for this 20th anniversary party. So I also realized I just said shindig, which we're just going to move on from that one. Anyway, so we're going with greatest number of people. So we know that it has to be less than or equal to 5,000. So if you remember that chart we went with, like the maximum, you're dealing with like a less than or equal to or greatest, things like that. So think about it in terms of we want to get as close as possible to $5,000, and it's okay if we spend $5,000 because apparently that's something that we're hoping to do. Anyway, so we're spending $36 per each person, and I want to figure out how many people. So that's my variable, right? Because that's the thing I don't know, right? We're trying to figure out of people. So we don't know how many people, but we know each person we have to spend $36. And then no matter what, we're just spending $70 on cleanup, which honestly feels like a deal. I feel like we're overcharging on the people, but I feel like we're undercharging on just the general flat rate, but okay. Anyway, so we'll solve this the same way we would solve any other problem, minus 70. So I get 36 people, 36 times the number of people has to be less than or equal to $4,930. Okay, so I'm going to divide both sides by 36. Now I would get that 4,930 divided by 36 ends up being that people is less than or equal to 136.94, and then my 4 is repeating. So if you were to put that as a fraction, that would have been 2,465 over 18. Usually I'm pro fraction, but in this case, I feel like this is a little bit more easy to deal with in terms of people numbers. So obviously, I'm not going to invite 0.9444444 of a person. So this is what would make them equal right here. The 136.94444, so on and so forth. Haha. That would make them equal. So we're saying the largest number of people that we could invite would be if we have to round down, right? We can't round up because then I'm over budget by an amount. Probably not much, but you are over budget. So we'd have to round down. And the closest number that we would round down to would be the 136. So we would have 136 people attending this anniversary party, which, I mean, hey, good for them. They're having an anniversary party. They got 136 people. Good for them. All right, moving on. Let's go down here. Okay. So now, so now we're dealing with a situation where we're comparing things. How lovely. Plan 1 charges $33 per month. for unlimited phone calls. Plan 2 charges $19 per month plus a 4 cent per call. Okay, so this first one, we're just dealing with a flat rate of $33 each month. And then on the other side, we're dealing with a situation where we have $19 per month as a flat rate plus 0.04 per call. All right, so we're using an inequality to find the number of calls for which Plan 1 is more economic than Plan 2. So basically, our situation is we want to figure out where Plan 1 is less than Plan 2. Okay? I help if I write the numbers. Plan 1 is less than Plan 2. So in our lovely instance here, we're saying Plan 1 is just $33 this month. Okay? We're just looking at this on any monthly situation. I'm not looking at a yearly situation, just looking at it for a month. All right? And then Plan 2. Well, that's $19 per month plus 0.04 per the number of calls. And that all I'm doing to get these numbers, I'm just saying how much is it going to cost me each month. And this month it just cost me $33. This month it cost me 19 plus 0.04 cents per phone call. And you can already tell that you're going to need to make a lot of phone calls for this to be a valid, for this to be more expensive. Most times in real life you would be paying that much like per minute, but I guess in this scenario we're just going by per phone call. Anyway, so now we just have to solve this the same way we would solve anything else. 19, so that'd be 14 is less than 0.04 cents times the number of calls. Now I have to divide by 0.04. 0.04. 14 divided by 0.04 is 350. Okay, so if my number of phone calls is less than 350 degrees, right? So essentially what this is saying, if 350 is less than the number of phone calls I make, then we would have ended up in a scenario where this side is better, right? But if we're making more than 350 calls, it's better to choose Plan 1, all right? So what the heck does this mean, right? I think sometimes we end up in a scenario where 350 is less than C. It's a little hard to deal with. So you could just essentially rewrite that as if the number of calls is greater than 350, then this is true, is what we're saying here. If my number of calls is greater than 350, then it is cheaper for Plan 1 compared to Plan 2, right? Because if it's greater than 350, Plan 1 is less than Plan 2. If your number of phone calls is less than 350, Plan 2 is going to be cheaper than Plan 1. So I've already kind of answered part B here, right? Because what we're saying is if I'm making less than 350 phone calls, I should stick with Plan 2. If I'm making like 350 phone calls, which in a 30-day month is like 12 phone calls a day, roughly 11 and 2/3 phone calls a day, roughly, then we would, I forgot where I started that sentence. So if we were going to be making more than 350 phone calls a month, we should go with Plan 1. If we're going to be making less than 350 phone calls, we should go with Plan 2. I don't know who's making 11 and 2/3 phone calls to local people per day, but it's not my decision. Anyway, moving on, last situation here. Luke and Aisha are traveling on the same road in the same direction. Oh, how nice. Luke is driving at a rate of 50 miles per hour, and Aisha is driving at a rate of 55 miles per hour. Write an inequality to solve when Aisha will be ahead of Luke on the highway. Let X represent the time in hours. So basically here, we are dealing with a scenario where Luke is going at 50 miles per hour. So here's my Luke. He's going 50 miles per hour for an amount of hours. Okay. Oh, we're letting X, sorry, how if I read the question? We're letting X be the number of hours. Right, so if I'm doing 50 miles an hour for X hours, that's how far I go. That's a distance. Right, this is distance equals rate times time. Come back to it. Now Aisha, she's going at a rate of 55 miles per hour. So after X hours, she's gone 55 miles per hour, right, for X hours, so she's gone that far. Now, we're told based on this diagram here that Luke is about 15 miles ahead of Aisha, right? So because if they were right next to each other, it'd be pretty much immediate that Aisha is in front, right? So we're saying we want Aisha, when will she be in front? So our goal is to find out when Aisha is greater than Luke in terms of distance, okay? Now Luke here, he's got a 15-mile head start. So he's going this distance, but he already has 15 under his belt. I don't know, he started early, whatever. And she's just going 55x, all right? So I'm just gonna simplify that. So I get 15 less than 5x. So I would get 3 less than x. So basically, whoop, wrong letter, wrong number. So basically what we're saying here is that when my number of hours x is greater than 3, Aisha is going to be further along the road than Luke is. So what does that mean? At 15 hours, at 3 hours, they're going to be directly next to each other. And then after that moment, she will be in front. Assuming they keep a constant pace of exactly 55. They put on cruise control. They're on the highway and they put on cruise control. Okay. So that's how we're going to explain that. So I hope this helps with solving inequality word problems. Please let me know if you have any questions. Have a great day.